All right, so welcome back for another circuit design tutorial. We are going to build off of the project we did last time with the TP4056 LiPo charger, and we're going to modify that. So the original one will output a 5-volt charge for powering a variety of like Arduino-based projects, pretty much anything you need 5 volts for. This version, I want to do a modification to it that is going to downstep it to 3.3 volts using an MCP1700. And so I'm pulling a lot of inspiration from this Random Nerds tutorial where they built a solar-powered ESP32, which is pretty cool. But the part of the circuit that I'm really going to focus on is just adding on these 3 additional components to make it for usable for any ESP32 project. So let's get started. So I'm actually going to clone the project that we did last time, and I'm going to change this to a 3v3 version for 3.3 volts, and we will click OK there. And over here, yeah, we should see now that we have a 3-volt version that we can play around with. And we're going to update our title to v3. Okay. And so we need to go do, just like usual, a little bit of shopping. So we're going to pop over to LCSC. And we want to see if we can find this MCP1700 3302E. That is a mouthful. And so we're actually gonna bring this over here so I can see both. So MCP1700 3302E. Let's see how close to something like this we can get. Aha! Ooh, availability is, yeah, that's okay. So, because I usually buy these on Amazon anyway, so it's okay that they don't have it in stock, but they do have it, which is good. So that means that we can come over here, and we're going to add a new section in here, and we'll call this 3 volts, 3.3 volt. Okay. And let's add in this part. And there it is. It's in their extended part library, so that means that if they ever have any in stock, that they would be able to populate it on a board for you, which is pretty cool. And okay, and we're going to drop it right there. Okay, and then we also need a 100 nanofarad capacitor and then a 100 microfarad capacitor. Now I've used 100 nanofarad before, so I can actually just bring this guy across. But this 100 micro, I'm pretty sure we're going to need to add that in. So again, let's do a little bit of shopping. Let's go to just back to the home page. Capacitors. And we're probably not going to be able to get these in a surface mount version because they're these electrolytic can types, but we'll see. So we'll be able to quickly figure out by clicking on 100. Really? I am not sure about that. Yeah, because I think we're going to do an axial. But maybe somebody in the comments or chat will be able to tell me if you can really do that, because I'm pretty sure you're supposed to use the electrolytic for this type of stuff. But that is a question for the day. Okay, so let's look at, we got lots of options here. Because in the circuits that I've built, I use these. Let's just see what happens when we do this. In stock and apply. No results found. Okay. Let's apply here. And just see what we got. Oh, okay, here we go. Okay. That's maybe making more sense. So we got these tantalum type, which are really interesting. I've never used these before. And then these kind of electrolytic caps, which is more of what I'm used to. Well, let's explore. So let's go. Price going up. Yeah. So this is more what I'm used to. Lots of different sizes. I love one that kind of has a relatively small footprint. I know we're kind of limited to some extent on these. And then let's see. So I just can't. Yeah, like we'll see. There's actually 6 in that package size. Let's look at an 0805. 18. Let's just see what these look like. Multi-ceramic. Well, you know what? Let's explore. And it could be, you know what? Let's be bold. Let's just try it. So, I'm gonna go with one of these guys and see what happens. 41 cents, but I want it now. Okay, let's try it. And I'll report back if for some reason that doesn't work, or if somebody lets me know it doesn't work. Okay. So this should be so pretty straightforward. In this case, if you'll remember our original circuit, everything kind of comes out to this battery or this output, and I'm pretty sure. Because those are functionally equivalent in our circuit, everything just got called V out. Yeah, so we're just going to take this V out, and that out is going to come in, weirdly enough, into the in. And then we're going to have a new output called 3V3 that is going to come out this way, and then of course we've got our ground, which can kind of just hang out right over here, and then in close proximity to that, actually move these guys back in a little bit. There we go. So we'll have this 100 nanofarad and this 100 microfarad that are kind of daisy chained together around the ground, and then the V out. I'm sorry, the 3V 3 going out. So we will add these guys in. And I've had good luck with this circuit, so hopefully we'll be in good shape using it in this particular configuration. Okay. and we will need to go add this in to our circuit. So at this point then, we can go to Design, we can update our PCB, and so this is going to create all sorts of fun changes. Yeah. What's interesting is, we'll go ahead and apply the changes. I think we're going to, yeah, do some small changes here. So I don't know if we need this out anymore. So if we look over here, yeah, I don't know if we need this, because this is really going to get turned into the out for the ESP32. Because you wouldn't need to really pull 5 volts from this anymore. At least I don't think you would. So I think what I'm going to do is actually convert this to be a 3v3 flag. Ooh, hello. Kind of move this over here. We'll call this battery. Yeah, let's try that. So I'm not going to save the changes here. Don't save, because we're going to be changing a lot of stuff. All right, now let's redo that. Let's update PCB. Apply changes. All right, and let's see kind of what that adds to the mix. So not a whole lot. I'm just going to go ahead and delete my power and ground planes. One thing I always like to do is come in here and just literally turn those off so I can see what I'm doing. Okay, and it looks like we're going to need to extend this out just a little bit. So we're going to move that. Relabel this to 3v3. And then we gotta think about where we want to shove all of these new components. So unlike in the last video, I'm going to try to make sure I have all the components before I place them. Last time I forgot to include one. Okay. So I could probably get away. That is a chunky capacitor. So what if I do something like this? I'm going to ditch this guy momentarily. Guys up just a bit, and maybe move these guys in. So just here. Wants me to sneak that guy in there. Okay. We might be able to make that work. I wonder if I rotate that guy just a bit. Yeah, that untangles it just a little bit better. So we're going to grab that. And flip it around over here. Okay. So, if we're on the top layer, should be able to get that over there. those guys out. Make that just a little bit easier to see. Yeah, now I gotta kind of decide what I want the power and ground plane to be. So I'm thinking that it's probably going to be BAT is going to be the new power and ground plane. Let's have a look-see here. Because there's all the grounds. Right, and I do need to make sure that this capacitor gets properly grounded. And these as well. So if I drop a ground in there. Cool. Okay. That should be okay. So let me just double check. So I should have just, yeah, battery and ground should be the only things that aren't percent. I'm going to sneak these labels in here. Oh, and you know what I need to do? That's something I kind of neglected last time. So whenever I've got these terminal connectors, sometimes it's not immediately obvious which one's power and which one's ground, and it would be really bad to get it backward. So I usually like to do just a little plus minus. And let's change that height to 1.5. Yeah, and let's just stack that right there. Just so that you don't hook it up backward. Because that would be bad, and I've done that before. So just a nice little signifier so that you know, don't hook this up backward. Okay. So I think, I'm going to go ahead and save that. I think we're ready to, refresh that. I'm just going to make a couple small adjustments. I just like to make sure all my labels are looking good. I know they're not always the prettiest, but I'm going to try to do what we can. Set that guy right there. He'll be fine. Don't do that. Just cleaning these up just a bit. Okay. All right, let's see what we can do. So we'll start off. I'm always kind of superstitious about whether to do the ground plane or the power plane first, but we're going to do the power plane just to make sure all those get hooked up. So we're on the bottom layer. We'll do our net. And, oh, it helps if I have a board outline first. Let's draw a board outline. Okay, now let's put in a power plane. So ground. And hopefully that doesn't leave us with any... Good, okay, so that took care of all the grounds. Now, real moment of truth, this is always a tricky one. Oh, this is going to be the battery. Okay, and for this, yeah, we're going to come across. Okay, so we see a small break there. We'll see if that broke anything. Aha! It looks like, despite a couple of little islands, it looks like that's okay. Let's go over here to... This is a 3v3. Let's take a look at how we did. Ew, gross. Alright, we don't want the silk screen running into there, so let's change that up a little bit. Need a room to move it. That kind of just more in the center of the board. Let's have a look-see. It's looking pretty good. Still crowding a little bit. Gotta work on that. Okay. This is a micro USB. Boom. A little bit more breathing room. There we go. Final check. Much better. Okay, so that's a pretty quick one. Like I said, this is kind of a modification on the previous board that we made, just with the emphasis of providing a stable 3.3 volt power supply for any ESP32 projects that you might be working on. So this is something I'm thinking about working on for a smartwatch project, and so yeah, it's going to be super important to kind of think about cramming this into the smallest possible footprint that I can. So right now we're at 35 by 15 millimeters. So yeah, we will see. A couple things that I'll be able to get rid of, I think, for the smartwatch project is probably these two LED indicators, which is going to get rid of these resistors. So the input will go away. We'll just have the USB connector, and then the battery will get hooked up to the LiPo battery that'll be on board. And then this will just be integrated into the ESP32 power supply port. So I think outside of that, we'll add an OLED screen, and an accelerometer, which is going to have some additional circuitry. Yeah, and then the ESP32 module. So it's going to be a pretty tight build, so be looking for that soon. In the meantime, actually managed to getting some good social setup. So we do have the YouTube channel to check out, and so that's Rainbow PCB, as well as a Discord channel that you can join. And so I'll link all the socials in my profile. But yeah, feel free to check out the recording on YouTube if you need to recap on this. And all of the links to these boards, I do open source all of this. And so I'm on open source hardware. And so I'll include the links on my YouTube video of this if you want to actually access this board. Thinking about trying to get these produced and set up so they'll be available for sale for anyone who just wants to get them direct, or you can always download the boards and get them produced yourself. And yeah, I think that's all for today.